Hello everyone, welcome to my channel. I am Gayithri. Today let us discuss about polymers. What are polymers? So let us write the definition for polymers and let me explain you about polymers. Okay. So polymers are initially we can call this one as a macromolecule, and these macromolecules can be formed by the repeated combination of simple molecules is called polymers. Okay, so here the polymers are macromolecules. These macromolecules can be formed by the repeated combination of the simple molecules. These simple molecules can also be considered as monomers. They are also considered as monomers. So then, what are these monomers? Let me explain about the monomers now. So monomers. So the name itself it is indicating that mono means one, single, right? Mono, one. So mers means the formation or combining together. So monomers in the sense a simple molecule with two or more binding sites for the formation or for the formation of polymers, for the formation of polymer long chain is called monomer. So we can say that monomer is a simple molecule, and this simple molecule should have two or more binding sites. Why it should have two or more binding sites? Because these two or more binding sites, it will be helpful to combine with any other monomers. So hence, by combining the monomers each other, we can get a long chain of polymer. So hence, it is called as monomer. Now let me give an example. So we know alkene, right? So alkenes. So for example, alkenes can be written as like this, right? So CH2. So this is considered as an alkene. So alkene is the best example for monomers. So such type of many number of alkenes can combine for the formation of polyalkenes. So the formation of the combination or repeated combination of such type of alkenes are considered as polymers. Now let us see the next definition is considered as polymerization. Okay, then what is this polymerization? So the polymerization is nothing but the process of formation of a polymer by combining simple molecules or monomers is called polymerization. So the formation of polymer by combining simple molecules or monomers are called polymerization. Now we have taken this alkene as an example. Now let us see how this alkene can form a polymer. So alkene is considered as, let me write the structure of alkene like this. So this is the structure of alkene. Now we can break the bond. The double bond which is present here, we can break one of the bond, and by the breaking of this bond, it can form a radicals on these two carbon atoms. How we can write the radicals on the carbon atoms? So we can write the carbon atom which is connected or bonded with the two hydrogen atoms is having one radical on each carbon atom. Suppose such type of, this is considered as monomer now. So this is considered as a monomer. Suppose such type of one more monomer is going to combine. Suppose such type of one more monomer is going to combine. Then we can say that carbon atom which is having a radical. So this is one more monomer. So this is monomer 1 and this is monomer 2. So if I am going to combine these two monomers, the radicals of carbon atom can combine with each other for the formation of new bond. Why? Because as we know that to form a single bond we need two electrons. So hence these two electrons can be taken by these two carbon atoms, and hence a bond can be formed by these two carbon atoms. So hence this can be considered as, so the carbon which is having a radical is shifted and it has formed a new bond, covalent bond, sharing of electrons is called the bond which is formed by the sharing of electrons is called covalent bond. So we can consider that these two carbon atoms have shared the electrons and it has formed the new covalent bond between these two carbon atoms, and the remaining carbon atom will be having the radical as it is, and the hydrogen atoms will be present like this, right? So this is what we can say, this carbon will be having radical and this is hydrogen, this is hydrogen. Suppose if one more monomer is going to combine, the same type of one more monomer is going to combine, then we can say that the monomer which is having radical, can again combine with the radical of this carbon atom. This radical, the electron of this carbon atom and this electron of this carbon atom will combine for the formation of new bond. Like this, if many number of monomers combine like this in the repeated form, so they can form new bonds between each other for the formation of polymers. So hence this polymer can be written as carbon atom which is having a one more carbon atom, and this carbon atom can combine with even more monomers, and this hydrogen atoms will be as it is. So hence this carbon atom will be having radical. So hence I can write like this. So this bond can combine with one more monomer, and this bond can also be combined with one more monomer. So like this, if I add 5 number of monomers, the 5 number of monomers will share their lone pair of radicals, and they will form a new bonds between each other. So hence it depends on the number of monomers, hence it is considered as N. So N means N number of monomers can combine with these polymer. So hence polymers are nothing but, so many number of simple molecules can combine repeatedly and they can form a macromolecule. This is considered as a macromolecule now, and this is said to be polymer, and this polymer can combine with even more monomers for the formation of long chain. So this is what we can say, polymers. Now let us see the definition of degree of polymerization. Degree of polymerization. What is this degree of polymerization? Have you heard about the degree of polymerization anywhere? Absolutely. So the polymerization means, initially we know that the polymerization in the sense formation of polymers, right? So polymerization in the sense we came to know that polymerization means formation of polymer. So how we can form the polymer? By the repeated combination of monomers we can form the polymers, right? So in the same way, so the degree of polymerization means the number of monomers present in a polymer is called as degree of polymerization. So this is what the general definition we can give, degree of polymerization. So here you can say that degree of polymerization means the number of monomers present in a simple molecule, or a number of simple molecules present in a polymer is called as degree of polymerization. In general we can give this definition, but if we are going to give one more definition is there for degree of polymerization, that can be defined as it is a ratio of molecular weight of a polymer to molecular weight of monomer. So this is one more definition. So we can give the degree of polymerization. In general, we can define degree of polymerization as the number of monomers present in a polymer, right? But degree of polymerization can also be defined as it is the ratio of molecular weight of a polymer to molecular weight of a monomer. So what I mean by molecular weight? So I think you people are familiar with molecular weight, right? So molecular weight is nothing but it is a sum of atomic weight of each atom in a molecule is called molecular weight, right? So the definition of molecular weight is very important for second PUC students. Molecular weight is nothing but it's the sum of atomic weight of each atom in a molecule. Then what is this molecular weight of a polymer? So the molecular weight of polymer can be defined as molecular weight of polymer can be defined as the sum of atomic weight of each atom in a molecule present in a polymer. So right, so we came to know that the definition for molecular weight can be defined as it is the sum of atomic weight of each atom in a molecule. So if that molecule is present in polymer, so then the total number of molecules which are present in a polymer will be having atoms, and that atoms will be having atomic weights. So hence the sum of all the atomic weight of each atoms present in a molecules of a polymer, then it is considered as molecular weight of polymer. Then how can we define molecular weight of monomers? Try write this one by your own. So I'll explain you once, you write by your own once. Okay, then molecular weight of monomers, how can we define this one? So molecular weight of monomers means the same thing, the sum of atomic weights, okay, the sum of atomic weight of each atom in a molecule which is present in a monomer is considered as molecular weight of monomers, right? This is how you can give definition for molecular weight of a polymer and molecular weight of monomers. Try write this one, okay? Try write this definition by your own. And hence the molecular weights can be, we can have two types of molecular weights, right? So the molecular weight, we will be having two types of molecular weight. So how we can define that, or how we can write the formula to calculate the two different types of molecular weights? The first one is considered as number average molecular mass. Number average molecular mass. And the second one is weight average molecular mass. Weight average molecular mass. So these are the two types of molecular weights. So here the number average molecular mass is denoted as Mn bar. Okay, so number average molecular mass can be denoted as Mn bar. Weight average molecular mass can be denoted as Mw bar. So how can we write the formulas for Mn bar and Mw bar? So let us write Mn bar is equals to N1 M1 plus N2 M2 plus N3 M3 and so on till infinity you can write. Okay, this is numerator. So in denominator, it's the sum of total number of molecules. So n1, n2 plus n3 and so on. So this can also be written as summation, right? So this can also be written as the summation of ni mi divided by the summation of ni. So this is how we can write the formula to find out mn bar, right? So this is the formula to calculate mn bar. Now let us see mw bar. So mw bar means weight average molecular mass, where weight average molecular mass can be defined as n1 m1 square plus n2 m2 square plus n3 m3 square and so on divided by. So now we can multiply. So here we will not get the sum of this total number of molecules present in a polymer, but here the product only used to come like n1 m1 plus n2 m2 plus n3 m3. So this is how we can write the definition. We can write the formula of weight average molecular mass, right? So weight average molecular mass can be written as n1 m1 square plus n2 m2 square plus n3 m3 square and so on till the nth term. You can write the formula divided by n1 m1 plus n2 m2 plus n3 m3. So this can also be written as the summation of ni mi square divided by the summation of ni mi. So this is how you can write the formula to calculate weight average molecular mass and number average molecular mass of a molecular weights. So this is about the types of molecular masses. So now let us recall what we have discussed in this class. So the first one is the definition of polymers. So what do you mean by polymers? In the sense, we can say that polymer is a macromolecule, and this macromolecular compound or molecule is formed by the repeated combination of a simple molecules, and that simple molecules can also be considered as monomers. Where now we have to discuss about the definition of monomers. Mono means one. One means it is a simple molecule. So hence you can say that a simple molecule with two or more binding sites for the formation of a polymer, and that binding sites is to combine with even more monomers, right? So hence we can give some examples like alkenes. We can give adipic acid as an example, right? Adipic acid is also considered as a monomer, and we can give vinyl chloride as an example, right? So vinyl chloride is an example, and also we can give glycol, right? So glycol is one more example. Like this we can give many examples for monomers. And this polymerization means it's a process, okay? Polymerization, polymer, see? Polymer means by the combination of or repeated combination of monomers we can form a polymer. So hence the process of formation of a polymer by combining simple molecules or monomers we can form a polymer, and this process is considered as polymerization. So we can give some examples. Here we have taken example of monomer as an alkene. So hence we can write the reactions for alkene only. So here the alkenes are which are having double bonds between two carbon atoms. Here one of the bond is broken into two carbon radicals, and one radical is shifted to this carbon atom and another radical is shifted to this carbon atom. So now we can write the structure of this alkene as like this. So here we will be having carbon atom. So the double bond is shifted as one radical on one carbon atom and another radical is shifted on another radical. So hence such type of one more atom or one more monomer is going to combine. So hence we can say that if two same type of monomers are combining, then the radicals are, it is not like the monomers should be same. We can say that here we are taking the same type of monomers, and hence I am mentioning if we are going to take two similar atoms or similar monomers, then the radicals of carbon atom will share for the formation of new covalent bond, and this covalent bond can be formed between these two carbon atoms. and hence we'll get the product like this. So we'll get the product like this, but remaining two carbon atoms, the adjacent carbon atoms will be having the same carbon, will be having the radical as it is. So if we combine one more monomer, again these two radicals will combine for the formation of new bond, that is covalent bond, and these two carbon atoms will be having radicals. So these two carbon atoms will be having ability to combine with more number of monomers for the formation of new polymers. So hence the structure of that polymer is considered as carbon which is having single bond, and these two carbon atoms are connected with two hydrogen atoms, and each carbon atom will be having one carbon bond. These bonds can combine with even more monomers for the formation of long chain. So this long chain is considered as number of monomers. So hence we can combine 10 number of monomers, we can combine 5 number of monomers, or we can combine 100 number of monomers. Hence N is considered. N means the number of monomers. Hence it is considered as a polymer, right? So hence what is degree of polymerization next? So degree of polymerization means we came to know the definition of polymerization. We have seen the mechanism too, right? So polymerization is the formation of polymer. We came to know that. But for the formation of polymer, in that polymer, how many number of monomers are present is called degree of polymerization. This is in general, right? So this degree of polymerization can also be defined as it's a molecular weight of a polymer and molecular weight of a monomer. So it is the ratio of degree of polymerization is the ratio of molecular weight of a polymer to molecular weight of a monomer. Then you should know about what is molecular weight of polymer, what is molecular weight of monomer. So we know about the molecular weight of polymer, molecular weight, definition of molecular weight that we have discussed or we have studied in second PUC. So hence we can say that so these two, molecular weight of monomer and molecular weight of polymers, can be defined. Before defining these two, we should know about the definition of molecular weight. So what is molecular weight? In the sense, molecular weight is a sum of atomic weight of each atom in a molecule. So it is the sum of atomic weight of each atom in a molecule. Suppose if you want to define the same molecular weight of polymer, then we have to say that the sum of atomic weights of each atom in a molecule present in a polymer is called as molecular weight of a polymer. Then how can we write definition for molecular weight of monomer? Please try write this one by your own. So I will define, so you just listen and try to note down this one. It is the sum of atomic weight of each atom in a molecule which is present in a monomer. Right? So here the molecule should be present in polymer, but here the molecule should be present in monomer. So this here the molecule should be present in polymer, and here you have to mention the molecule which is present in monomer. So hence this is considered as weight, molecular weight of a polymer and molecular weight of monomer. So later we'll be having the types of molecular weight. So here we'll be having two types of molecular weight. One is number average molecular weight, Mn bar, and weight average molecular mass. So number average molecular mass and weight average molecular mass, these two can be denoted as Mn bar and Mw bar respectively. So here we can write the formulas for these Mn bar and Mw bar. Mn bar in the sense this is N1 M1 plus N2 M2 plus N3 M3 and so on, and numerator, and denominator you can write N1 plus N2 plus N3 and so on. So here the formula can also be written as summation Mn bar is equal to the summation of Ni divided by summation of Ni. So here we'll be having a formula for weight average molecular mass. So weight average molecular mass can be written as N1 M1 square, N2 M2 square plus N3 M3 square and so on, divided by N1 M1 plus N2 M2 plus N3 M3. The formula can be denoted as Mw bar is equal to the summation of Ni Mi square divided by the summation of Ni Mi. This is about the polymers. So this is the basic terms which are involved in polymers, which are very much important for all streams of engineering students and PU students, BSc students, MSc students, pharmacy students, everyone, you people should read about the polymers. So if you like this, please do subscribe, like and share it. Thank you so much.